Let us try to understand what is meant by clock latency. So the set clock latency is one of the Synopsys design constraints. Set clock latency command is used to define the estimated clock insertion delay during synthesis. This is primarily used during the pre-layout synthesis and timing analysis. The estimated delay number is an approximation of the delay produced by the clock tree network insertion. So this is done during the layout phase. So in order to try to understand clock latency, we need to know what is meant by source latency and network latency. So see here, latency means the amount of time taken by the clock to reach from the clock port to clock pin of sequential element. There are two latency components, as I told you. First one is source latency, next one is network latency. So you need to understand this figure. So the clock will get generated by using phase lock loop, and this clock which is generated by PLL, it has to reach to the clock port, and from the clock port it will reach to the clock pin of the flip-flop. So the time taken by the clock to reach from PLL to clock port. Here this clock port is also called as clock definition point. It's called as source latency, and from clock port to clock pin it is called as network latency. To specify source latency, hyphen source switch has to be mentioned in the command. Source latency is from PLL, that is from oscillator to the clock definition point. Network latency is from the clock port to the clock pin of the flip-flop. So try to understand this figure clearly. This is PLL, this is clock port or clock definition point, and this is clock pin of the flip-flop. So coming from PLL to clock definition point, it is called as source latency, and from clock definition point to the clock pin, it is called as network latency. So first, let us try to understand the syntax of set clock latency according to design compiler. This is from Synopsys. So set clock latency, and these are the switches. Hyphen rise, so it specifies the clock rise latency. Fall will specify clock fall latency, and min and max. Here min specify clock rise and fall min condition latency. Hyphen max will specify clock rise and fall max condition latency. And if you want to mention as source latency, you need to make use of this switch called as hyphen source. So to specify clock rise and fall source latency. Next, coming to early and late. Early is something which is used for hold. Late is something which is used for setup. So hyphen early, it specifies early clock source latency, and hyphen late, it specifies late clock source latency. Next one is hyphen dynamic jitter, which is used to mention clock jitter. Next, hyphen clock followed by clock list. So we need to specify the list of reference clocks and delay number. So that is nothing but clock latency and object list. So it can be clocks, pins, or hosts. Next, coming to the syntax according to Genus, which is from Cadence. So usage is set clock latency, switches are rise, fall, min, max, early, late, clock gate, source, and clock. So go through this slide. So almost the usage will be same. Rise will mention rise latency value. Fall will mention fall latency value, and this is minimum value, maximum value, early value, late value. This is for clock gate. This is source. That is, you need to choose either source or network latency, and hyphen clock followed by the clock list, and some value we need to give followed by the objects, which can be clock, port, pin, or hierarchical pin. Next, coming to the syntax according to the prime time. So set clock latency followed by the switches. So we have already seen hyphen rise. It specifies clock rise latency. Fall will specify clock fall latency. Min is specify clock rise and fall min condition latency, and this is specify clock rise and fall max condition latency. Hyphen source to mention source latency. Coming to dynamic, it specifies dynamic component or rise and fall source latency. Hyphen late and early. So hyphen late means it specifies clock rise and fall late source latency, and it specifies clock rise and fall early source latency. Next one is PLL, that is phase lock loop shift. Specify PLL related latencies, and hyphen generated. It specifies generated clock rise and fall source network latency. Hyphen primary specifies primary clock rise and fall source network latency. This is clock fall and clock rise. Specifies that the source latency tag should be applied on the fall tag of the clock, and here source latency tag should be applied on the rise tag of the clock. And this is something which is one of the switch called as SMS scenarios, followed by the delay number and the object list that can be applied at clock, ports, and pins. So these are the arguments. So I mentioned the detailed description of each and every switch, like what is clock, rise, fall, min, max, source, dynamic, late, early, and PLL shift. Go through this slide. So these are a few more switches, that is generated, primary, clock, fall, clock, rise. So go through this slide for more understanding. And this is about SMS scenario. So this is a detailed description about what is clock network latency and source latency. So for more understanding, go through this slide. So if you see this particular thing, to undo set clock latency command, use remove clock latency command. So while setting latency, we need to use, and for undo, you need to use remove clock latency. If the set clock latency command is applied to pins or ports, it affects all registered clock pins in the transitive fan out of the pins or ports. Directly setting a network latency makes the affected registers ideal. A warning is issued if the set propagated clock command has previously set a propagated attribute on the same object, that is clock pin or port. Clock source latencies are allowed only on clocks and clock source pins. The command does not check to see whether a clock specified with the hyphen clock option passes through the pins or pins referred in the object list. If a clock specified does not pass through the pin, the command has no effect and there is no warning about this condition. So to set, use this command. To undo, use this command. To see clock network and source latency information, including dynamic components, use a report clock command with the -q option. So these are some of the examples. So I have mentioned some of the examples which I will show you in the upcoming slides. So these are something which I have taken from the tool. And these are a few more examples. And in prime time, if you type as report timing -path type full clock expanded, you'll be seeing this particular report. So here starting point is from flip-flop 1 and ending point is at flip-flop 2. So here flip-flop 1 is rising edge triggered flip-flop, clocked on clock. Flip-flop 2 is rise edge triggered flip-flop, clocked on clock. Path group is clock and path type is max. If it is max, it is for setup. If it is min, it is for hold. Next, coming to the syntax from Tempest. Set clock latency followed by the switches. So here again the detailed description about what is source latency and what is meant by network latency. So let us see this. It specifies ideal internal clock latency and external clock arrival delay. So source latency, we have already seen this, specified using -source parameter, and it is a delay from the external clock generator to the clock port of the design. Applied when the clock is either ideal or propagated. Set clock latency set on a clock port as high precedence, then set clock latency set on a clock waveform. Specified on a clock waveform with both the set input delay command and the set output delay command. Next, coming to the network latency, that is prop tree delay. Default latency type, and it is a delay from the clock port to the register. So source latency is from PLL to the clock port. Network is from port to the pin. Applied only when the clock is ideal. When the clock is propagated, this delay is replaced by the actual clock tree delay. Specified on a clock waveform or a clock port is ignored if the clock is propagated. Set clock latency set on the timing pin has high precedence than the set clock latency set on the waveform. If there are multiple set clock latency and set propagated clock assertions within the clock waveform, clock root and clock endpoint, the clock assertion to the clock endpoint takes precedence. Specified on internal circuit pins or hierarchical ports and used in the fan-out cone of the network latency pin when a clock is ideal. So use the set clock latency command in the two ways. So we have seen already these switches: set clock latency -source, early, late, min and max. Use the following syntax for network latency associated with a clock signal. So for network latency, you need to use like this, and for source latency, you need to use the extra switch called as -source. You cannot specify -late and early parameters for network latency. Remember this point. -late and -early should be used for source latency but not for network latency. Specifying latency on a port or pin overrides any previous latency specified on the port, pin or waveform. The pin or clock list argument is a list of clock waveform names as specified by the create clock. So whatever the clock port names that you are using while using create clock, the same thing you have to use here. To specify clock latency on the clock pins, this is a command. Use the following syntax for source delay on a clock port. Set clock latency -source followed by you need to use either early or late. Next -rise and fall. Use the following syntax for network delay on clock pin. So set clock latency -min max rise fall. When a clock is ideal, the last specification along a path is used. This is useful when you want to intentionally skew the clock tree and model the physical hierarchical clock. So these are the detailed description of each and every switch that is present in set clock latency. Please go through this slide. So -clock followed by clock list associates clock latency constraints placed on the pin level with a specified clock. This makes it possible to specify a different latency per clock. Note, you cannot use -clock parameter with clock waveform objects. Next, coming to clock gate, allows setting the local clock latency value on pin or board objects. This setting overrides the existing latency value of clock gating cells and is used when performing timing checks against the specified pin or port. Next, -early and late. This should be used for source latency. So it specifies clock arrival time with respect to the early or late time of a clock signal. In setup analysis, launch path is a late path and capture path is the early path. You need to note down these points. For setup, launch path is late and capture path is early. In hold, launch path is early path and capture path is late path. So we know that for setup, generally required time should be greater than the arrival time. So required time is something comes under clock path and arrival time comes under the data path. So generally this data path will be having more delay and clock path will be having the less delay. So that's why capture path is the early path. But because it is having less delay, whereas the launch path is having the more delay, it is called as late path, and vice versa for hold. If neither parameter is specified, the default is both early and late. Use these parameters only with the -source parameter. You cannot use these parameters with network latency. We have already seen this point. And it specifies the clock latency at the given operating corner. And this is the important note that we see along with early and late. The min and max parameter refers to the operating corner, and the -early and -late parameters refers to the clock arrival time at the source. Use -early and late parameters with the source parameter to specify 4 different clock latency. So when you are mentioning source latency, then only we have to use -early and late. Next, coming to -jitter, it specifies a portion of source. Coming to -jitter, specifies a portion of source clock latency value that can have cycle to cycle variation when calculating CPPR, that is clock path pessimism removal. Adjust this portion is removed from CPPR adjust for different clock edges. Example setup, but it remains as part of CPPR adjust for same clock edge check, that is for hold. And coming to latency, it specifies the latency value as a floating point. Next, pin or clock list specifies the list of clock waveform names or the list of pins to associate with the clock latency. The pin can be a port or an instance pin. So setting source latency on a pin is ignored. So -max and min, it specifies the clock latency for a particular operating corner. Apply the max parameter to the maximum operating corner and min for minimum operating corner. Next, coming to -rise and fall. Next is -rise and fall. It specifies the rise and fall parameters to the waveform at register clock pins for ideal latency and to the waveform at the source for source latency. Ideal network latency does not change polarity when crossing negative unit arc. So we need to understand like what is meant by positive unit, negative unit, and non-unit. So positive unit means whenever input is rising and output is rising, this is called as positive unit. If input is rising and output is falling, it comes under negative unit. And non-unit is something which is depending upon the another pin, like examples are XOR and XNOR. Next, coming to -source, specify source latency. If you do not specify the -source parameter, network latency is applied. So if you want source latency, then use -source. If you're not using -source, then by default it will be network latency. And these are some of the examples. So I have captured few of the examples which I will be showing in the upcoming slides. So see this one, we have already understood what is this PLL, clock port or clock definition point, and clock pin. So from PLL to clock port, it is called as source latency, and from clock port to the clock pin, it is called as network latency. If you are using -source, then source latency will be applied. If you are not using -source, then by default, network latency will be applied. And one more point, -early and -late should be used only while giving for source latency, but not for network latency. So see this syntax, set clock latency, -rise call, min max, and -source, early late, followed by -clock, clock list, and delay followed by object list. So we have seen this one, early means hold, late means setup. So for hold, it will be for shortened parts, and for setup, it will be the longest path. So see this example, set clock latency, -source. As we are giving source, it is called a source latency, and here -early. Early means it is hold, that is, we are applying it for the shortened path. So -early 0.3 is the value, and we are applying for the get clock CLK. So source latency for shortest path. If you want source latency for the longest path, then you have to give as set clock latency -source, here which is late. So here late means setup, but setup it will be the longest path. Suppose if you are not giving anything like set clock latency 0.5 get clock CLK, as you are not giving source, By default, it will be network latency. These are few more examples. Set clock latency 1.2. This is a rise, and get clocks. This is the clock port name. Next one is set clock latency value. This is for fall, and we are applying it for all clocks which are present in our design. Next, set clock latency. This is a value, and this is source latency as we are giving hyphen source, and this is a min value for get clock CLK, whereas this one is max value. Set clock latency. This is a value for source latency, and for max get clock CFG clock. We have already seen the same figure from PLL to clock definition point. It is called as source latency, and from here to clock point it is called as network latency. So be clear with what is hyphen source, and if you are not giving hyphen source, what will happen. So in this video, we have understood what is meant by set clock latency.